the standard deviation, and I remember going over it, so I don't remember if we finished it. So what I thought we would do is just go over a problem all the way through, because this is the type question I will ask you on the test from 6.1 and 6.2. I don't know what 6.2 is yet. We'll get there when we get there. So first, you're going to be given a table, a binomial distribution, whatever. Okay, there that is. So you might want to jot that down. Zero things happening, one thing happening, two things happening, three things happening. And then you're going to be asked to find the mean and the standard deviation. There's the mean. And the standard deviation is as follows. Now that's the formula I use. I don't like the other one. Well, I just don't use it. So standard deviation supposed to be an arrow to get it. I can't use that either. There. So go ahead and start your columns, because that's basically what you need to do, is start your columns just like we used to do with the frequency distribution. Once we do one or two of these problems, then you'll be good to go as far as this section goes. Okay, this requires a pencil, piece of paper. So if you don't have those, then just leave. Okay? Now, if you don't have anything, if you don't know what to do, first thing to do is recopy the table that you have in your own columns. That's the first thing you do. And maybe that may trigger, okay, then I need to multiply the first column times the second column. That's called x times p of x. That may help you. I don't know. So x, 0, 1, 2, 3. And then p of x is going to be 0.01, 0.10, 0.38, and 0.51. Now I've already mentally checked to make sure that it's what? Equal to 1. I think it is. But just to check. This thing's all messed up. Now I got it. Let me make it big now. There we go. Check it and make sure. And it is 1. And each one of these is between 0 and 1. There's no negatives. And there's no whole numbers. So everything's good. Now, you look at the formula. In order to find the mean, I've got to multiply x times p of x and then do what? What? The sum of all. Yes. The sum of all. That's how you say it. Okay? Not no. And have me decipher what that means. Okay? So I'm going to take x times p of x. And then copy that down. And then add it up. And when you do that, you have your mean. So everybody should be able to get the mean. As I told you the first week of class, or the second week of class, the two most important numbers in statistics and probability is the mean and the what? Standard deviation. If you don't learn anything in this class, those are the two, that's the one thing you should know. The two most important things are the mean and the standard deviation. So now we have to find the standard deviation. So we look at in order to do anything, we have to read the directions. So we're going to read the directions, which is the formula. Do we have p of x? Yes, that's right there. Here's the mean, the square mean. We got that. We got the mean. So what do we need? All we need now is what? X squared. So that means we've got to make a column called x squared. I'm going to make it over here a little bit. X squared. That's going to equal this number raised to the second power. And then they will x squared times what? P of x. So that's going to equal this number times P of x is right here. And of course we add that number up. And then that number we subtract the mean squared. So I'm just going to go over here. And I'm going to say standard deviation, or S, is equal to this number minus, don't we take the square root of it? Yeah. So that'd be parentheses, this number minus this number raised to the second power, close parentheses, raised to the 0.5 power. And there's your standard deviation. So now, given the probability of something happening, we can actually say that the mean is equal to 2.39 Now you have your normal distribution, and you can actually draw, and even if you don't even know the mean or the, you can figure the mean or the standard deviation and say, okay, what is the chance of this thing going to 4 games? Well, 4 games would be unusual. What's it going to 5 games? 5 games would be an outlier. Or this could be girls and boys and the parent having 3 kids, whatever, having 0 boys, 1 boy, or 2 boys, or 3 boys, or whatever the case may be. Whatever, this could be games in a series, it could be children being male, whatever the case may be, and now you've got your normal distribution over here to ask, what is the chance of 1 happening? Well, the 1 is normal because it's in the 95% range. What about 4? 4 is not normal. 4 is unusual because it's outside the range. See, and that's the part that's important in 6.1 and 6.2, is to take something that's nothing but probability and being able to crunch out the mean and the standard deviation. The mean and the standard deviation is important for us to see, not me as a math teacher, but important for you to see so you can see how everything stacks up. It's just like you in a classroom. All right, you're fixing to head out into the big classroom. You're going to get your degree, and you're going to head out to the big classroom. There are going to be so many times you're going to be wanting to find the mean and the standard deviation of anything to see where you sit, just like you did back in the classroom. If you get an economics test or a psychology test that everybody has bombed, the first thing you want to see is the class what? Class average. Well, you're going to transition from wanting to see where you stand in the class to where you stand in the office, or where you stand in the department or the division, or whatever the case may be. So there's going to be a lot of times, unless you're just one of those stupid employees, there's going to be a lot of times that you want to know where you stand, where your division stands, where your department stands. And that's why it's so important for you to be able to find the mean and the standard deviation no matter what you're given. Now, you can find the mean and the standard deviation of data, test scores. You can find the mean and the standard deviation of a frequency distribution, which means classes and head count. And now you're able to find the mean and the standard deviation given nothing but probability. Comprende? Or comprendo? Do you understand? Which one is it? Comprende? Okay. Comprende. No, I don't think that was. Comprende. Oh, forget it. Capiche? Okay. Let's do a nerd. I'm going to give you 2 or 3 of these. And that way, pretty much, if you fail it on the test, you what? Don't tell anybody because they'll know you're an idiot. Let me find another one and we'll just go with it as soon as I find one. I think that's the one we just did. Right there. There we go. I should give you this one. We'll do this one. National Center of Education Statistics. Let me just blow it up so y'all can. This one right here. Find the mean and the standard deviation of this guy. Right here. Parental involvement. The number of activities a parent of a 6th to 8th grade student is involved in. 0. In other words, parents don't care about the kid at all. 1, the parents care a little bit. 2, the parents care a good bit. 3, okay, it's starting to get weird. 4 events, you got a helicopter parent hovering over the student all the time. I'm sorry. So 0 event to 4 events. So every time you go to school, your parent is behind you. I wasn't that way. Nope. I'm kind of like 2, 1 or 2. Because eventually, what is that child going to have to do? Stand on his own 2 what? Feet. And get his participation award. My son got mad the other day because I told him that, Daddy, he said, why don't you let me play football? I said, because you ain't ready to play football yet. He said, why? Because you're not in shape. And he cried. I guess I should just let him go to the Y this year and get run over by a bunch of kids. I'm not going to do it. Got a 500 square foot gym in the house. He won't set foot in it. But he participates.
How old is he?
9. I started playing football when I was like 6 years old. Wish I hadn't started then. Then maybe when I got out of high school, I wouldn't have been burnt out with it. And back then, you only got a trophy when you won. What a concept. And if you lost, you lost. You were the loser. I guess I just need more unicorns in my life. Unicorns and pink skies. Where there is no terrorism. Are you going to go to Newberry?
Yes, sir.
They have a good veterinary program down there.
I'm doing occupational therapy. My grandparents got there. My grandma was a cheerleader. My grandparents.
I got a good friend that was a football player there. He played all 4 years.
Yeah, I signed this Friday to be the mascot.
Oh, well, that's good. That's a very, very, very demanding job.
I get a ton of scholarships though, so I was like signing up.
Go for it. No, you're supposed to whine and complain because nobody's going to pay for your education. That's what you're supposed to do. Oh my gosh. Have you heard that some college students at Emory University, Emory's like high up, are complaining that they're being, how do they put it? They're being, they feel very insecure, or they don't feel like they're in a safe place because Trump supporters are putting Trump 2016 on the sidewalk. So they're going to counseling. Yeah, wrote it in chalk. The United States is turning into a pansy nation. You ever seen Demolition Man? Do y'all watch movies at all? Sylvester Stallone and Sandra Bullock. Of course, it's a Sandra Bullock movie. But anyway, you need to watch it because the United States is turning into that city, San Angeles, where everybody walks around in togas. What is your debacle? I can't believe y'all have never seen that movie. Nobody in here has never seen Demolition Man. Okay, we're going to have a movie day in here one day. We're just going to go through and I'm just going to copy all the movies off my direct DVR and I'm just going to put them up. Y'all need to watch some movies because y'all been deprived. And you know whose fault it is? Your parents. Okay? Let's see if I can pull up the debacle scene. That's my favorite part of the movie. Well, I thought I was in YouTube. I'm not in YouTube? It's your debacle. I don't even know how to spell debacle. That's not how you spell debacle. How do you spell debacle? Of course, I'm asking class that don't talk. It makes weird noises. Well, I guess Demolition Man doesn't. Oh, Demolition Man. What's your boggle? I'm sorry. What's your boggle? Okay, I want to go see a movie. Dang old Kevin Costner, dang old Criminal. Y'all have any earthly idea what I'm talking about?
Nope, they switch bodies, but almost.
Yeah, I want to see that movie. First of all, Kevin Costner don't put out crap. Let's see it. I love that. Okay, I need to tell you what the story of this is. Okay, in the 80s, this guy, Simon Phoenix, was a real bad guy, killing people, blowing up people. And the only guy that put him away was Sylvester Stallone. Well, they both got cryogenics for imprisonment because they blew up a whole city block. And they got put into a piece of ice and frozen for like 100 years or whatever. So it's like, I think it's 50 years. 50 years later, the guy that's the head of the Pansy Nation wants this guy out so he can kill the guy that's challenging him. That's just a long story. So he's out, and he's trying to find a gun because they don't have guns in Pansy Nation. Yes, sir. Huh? Yeah. You've seen it? One person. Okay, good, good. All right. This guy, he's he's going to get a gun, and of course Sylvester Stallone says, this guy's going for a gun, and they say, no, you're crazy. He's going to do. Well, where's the gun? At the museum. And that's when they go to this. And then you get to see him meeting the first pansy. What is your boggle? This is the Donald Trump one. This is what I like about it. It's violent. Oh my God! Anyway, it's a good movie. You need to go watch it. If your parents give you permission. Oh, I didn't know it kept playing. We can sit here and watch the whole movie. And then, of course, Blondie. Oh, he makes a little snide comment here. Let me borrow this, Rambo. And he borrows it. There's the Pansy Nation. Anyway. Anyway, it's a good movie. Might want to ask your parents if you can watch it. Okay, shut up. All right, so anyway, that's Demolition Man. No comment.
That looks good.
Thank you. Thank you for the input, you know. All right, we'll go back to math since y'all are really wanting to do math. All right, so we take our handy dandy two-jigger out. And look, all we have to do is add a few. So I'm going to put one more in here. Insert 0, 1, 2, 3, 4. 0.073, 0.117, 0.258, 0.322, and 0.230. Y'all check my numbers. If my numbers don't come out right, then that means I gotta go through and change something. What y'all get? Okay, so now take your handy dandy. Here we go, 2.59. So if you have a parent that is participating in 5 events, then what can you say? They're crazy, all right? And if you have a parent 0 events, then they're DSS material, okay? That's a joke, ha ha ha. You know, y'all have been conditioned real bad. Not to say a word in class. All right. Any questions? Y'all not going to ask them anyway, so we'll move on. All right. there was any way I could do it, link math with movies, we would have a whole week of watching nothing but movies. Someone would turn me in. He doesn't talk about math. He watches movies. I'm not getting my money's worth. Right, Mr. Smith, you would do that, wouldn't you?
Yes, sir.
Oh, man. No, we're not doing all that. When I see something important, I'll let you know. I don't even know what section we're on right now. Okay. All right, page 317. You might want to write it down. Might want to write it down in your notes. Top of the page. Well, write those two down. The mean is equal to n times p, and the standard deviation is the square root of n times p times q, which q is the complement of p. Now I'm just going to give you an example of what this is. Let's say that I give you a problem and I say a coin has been flipped 50 times and has a probability of 0.45 being tails. What is the probability if the coin is flipped another 20 times or another 5 times? Of those 5 times, what is it? What is the probability of it being tails? In other words, I give you a number, I give you a mean, and then I give you asking another probability or whatever the case may be. And that's what these numbers are for. Now, these are easy questions. These are like very easy. Please don't tell anybody you missed one of these, because then you just can't multiply. Okay? They're going to give you a number like 0.5 and an n of 20. Well, what's half of 20? Okay. Are y'all going to keep disrespecting me, Mr. Smith? Are y'all going to keep disrespecting me?
Yes, sir.
You have done it all morning. Now, the third time, I'm going to ask you to leave. Are we good?
Sir.
All right, so 0.5 of 20 would be what? What's half of 20? 10. So your mean is 10. Then you go over and say, well, what's 10? What's half of 10? Because if P is 0.5, what's Q? Complement of P. 0.5. So what's half of 10? 5. And then take the square root of 5. I mean, you can do that in your head. So let's do one right here. We're just going to do this one. Right here. It says, problem, according to blah, 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 25% of all households are wireless only households. In a simple random sample of 300 households, determine the mean and the standard deviation, blah, blah, blah. They only give you two things to work with, and that is the n, and n is always going to be your what number? Your largest number. N is always going to be your largest number. So if N is equal to 300, then what's 0.25? P. And then what's Q? Okay, P is 0.25. What is Q? 0.75. Thank you. So the first thing we're going to do is multiply 25% of 300. Well, we know that 10% of 300 is 30, right? And a half of a percent, and 1% of 30 would be 3. So then you could do 5 times 3 is 15. So you could actually figure 25% is going to be what? 30 and 30 is, and then 15 is what? 65 or 75? Somebody help me out. So take your calculator and multiply 300 by 0.25, and you should get 75. That's your mean. Now to get your standard deviation, you take 75, which is N times P, and you multiply by Q, which is 0.75. And you do that in your calculator. So 75 times 0.75, and then take the square root of that. What do you get? 7.5. So you've actually got 75 in the middle, right? And then I'm going to add 8. 7.5 is 8. Did y'all took the square root of it, right? You got 7.5? All right, so 8. 75 plus 8, I have no idea. 83? What is it? 83. 83 plus 8 is 91. 75 minus 8, 67, and 67 minus 8 is 59. So if I was to ask you, let's say 300 households to determine the mean and standard deviation. So if I was to ask you, what about 50 households? Well, 50 would be what? 50 would be an outlier. What about 91 or 95 households? 95 households would be an outlier. So again, they're only giving you how many households, and they say that the probability of that household having wireless is 0.25. So you don't have any idea how many households has wireless. You have no idea. You just got a probability of 0.25 and a number of households. So it's kind of like you're getting blood out of a turnip. I mean, you're actually getting two numbers that are valuable out of two numbers that are what? Not so valuable. Very, very thin. Very thin. In other words, putting a lot of faith in these numbers. Okay? You'll get a couple of these questions on the test. And these you should not miss. If you do, you don't what? You don't tell anybody. Let's do a nerd. If I can find one, they got 15 different steps to it. We already did this one, didn't we? Oh, this one you have to actually find. Yeah, we've already done that one. Fine. Okay, here we go. Here we go. I don't want to do one. I'd like to do one where they actually give you. Okay, here we go. According to flightstats.com, American Airlines flights from Dallas to Chicago are on time 80% of the time, suppose 15 flights are randomly selected. Give me the mean and the standard deviation of those flights. So the mean is going to be equal to n, which is 15, times 0.8. Comes out to be 12, doesn't it? All right, so 12 is your mean, and you take that number and multiply by 0.2, which would be 2.4, and take the square root of 2.4, well, the square root of 2 is 1.41, so I guess what, 1.6? What does it come out to be?
1.55.
Okay, 1.55 against 1.6. Thank you. 1.6. So now, 12, we'll consider that to be 2. So that would be 14 and 16 and 10 and 8. So 17 flights being on time would be unbelievable. But the mean is 12. In other words, out of those flights, the 15 flights, 12 were pretty much on time. Okay, so as long as you know the two formulas, the first set of formulas and the second set of formulas, you can do 6.1 and 6.2. Capiche? Now, Chapter 7 is going to make up about 80% of your test. I guess it's Chapter 7. It should be area under curve. Let's see what Chapter 7 is. Chapter 6 in the old book. But let me get to Chapter 7 if I ever get to it. Yep. 80% of your test is going to come from this section. So this section right here, out of 20 problems, you're going to get 2 problems out of uniform distribution. Make sure you make a note what uniform distribution is. And I'll show you as soon as I get a picture of it. There it is. What is the only thing in our system, in our universe, that we do not have any control over?
The weather.
The weather? Time. Okay. Weather, yeah, I guess we don't have control over it. I think we do kind of, but we can predict it. But that's a good, I never thought about that. Weather and time. Anything else we can't control? But the only difference between weather and time is more predictable than weather. Okay? In other words, you know, if you live in South Carolina, you know that. Next week, we could have our heat turned back on. And then the next week, we can have air conditioning turned back on. Spring and fall in South Carolina is very unpredictable. Very. Where our summer and our winter, you know, we're going to have an ice storm. and we're going to have a drought. Okay, we know that. But time is about the only thing that we can draw a straight line on, and everybody would go, yeah, that's pretty much right, because we can't slow time down. We can't speed it up. Even though some people try to slow it down, it can't be slowed down. Slown. Is that a word? It can't be. You cannot slow it down. All right. So the only problem where you're going to have uniform distribution is going to have to do with time. Now, the way that you do this is I'm just going to snip this thing out because I don't want to draw it 15 times. Whenever you're given a uniform distribution, it's going to look like this. Now, most of the time, when you're given one, it's going to have to do with the class meeting at a certain time and ending at a certain time. I'll just make one up. Your math class usually ends at supposed to be 50 minutes. Supposed to end 50 minutes. This is a 1 hour class, not an hour and a half, so we're not talking about this class, okay? Your math class usually ends 50 minutes from the time it starts. You have conducted an experiment or an observation, I should say observation, that your teacher has a tendency to stop at 45 minutes. What is the probability of your teacher going 50 minutes? Okay. Now, the things that you can change here is, one, the area always stays equal to 1. So the area under this curve, even though it's not a curve, is equal to 1. All right? The thing that you need to figure is the height. The height is not going to be given. You've got to calculate the height. Right? These two things you got to plug in. Okay? So, usually your teacher usually stops at 45 minutes. Like 9 times out of 10, they stop at 45 minutes. So here is 50, and 45 is about right here. So you've actually got to find out what the height is at 45 minutes. Okay? So, 45 minutes, from 0 to 45 is 45 minutes. So, they're asking you, what is the probability that they will go 50 minutes? And you say, well, we don't have anything, we need to have this height. So, you go, okay, well, area equals length times what? Width, or base times height, whatever you want to call it. So 1 is equal to 45, that's that length right there, 45 times the height. Whatever this height is right here. And then that's going to be 1/45 is equal to width. So our height here is 1/45. And if you want to find the area from here to here, you would multiply, what's the length right here from 45 to 50? 5. You multiply it by the height, which is 1/45, which will give you 5 over 45, which is equal to 9. So you got a 0.9 or something probability. Whatever the case may be, I'll show you a better example here in just a minute. The whole concept I want you to get is right here. Area equals length times width. 1, find the height. Find the height with the area equal to 1. 2, once you find the height, find the new area based on this distance right here. Okay? I didn't exactly have the wording right for the problem, so we're going to go to one that does have the wording right and go from there. Okay? Let me do another one. Let me go back to the example. I usually do a crazy teacher example. Okay, here it is. I don't know what this is, but anyway, well, let me go to another problem. And they'll give us another example. Great. All right, well, this example, let's see what the imagine that a friend of yours is always late. Let the random variable x represent time, blah, blah, blah. Suppose your friend could be on time or up to 30 minutes late. X is equal to 30 with all intervals. X is equal to 30, blah, 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 0 to 30. Okay. So the next question says, what is the probability that your friend will be 10 to 20 minutes late? Well, 10 is going to be, trying to find the picture, there we go. 10 is going to be right in here, 10, 20, 30. So we'll make 10 be right here, and 20, oops, that sucks. There, 10, 20. So what would the probability, what's this area right here? Well, we calculated that the area, the height is 1/30. So we need to calculate this area. What is the distance? So area is equal to 10 times 1/30. which is 0.33. So what is the probability that your friend is going to be 10 to 20 minutes late? 0.33. So you might as well go ahead and grab a chair and sit with that probability. It is 10 a.m. There is a 20% probability that your friend will arrive within the next blank minutes. Well, 20%. Let's find 20%. What are they telling you if they tell you that the area is 20%? Well, they're saying that 20% is equal to base times what? Height. Which one do we know? Do we know the base or do we know the height? We know the height. So 0.2, that sucks. 0.2 is equal to base times 1 over 30. How do you get rid of multiplying by 1 over 30? Multiply by 30 over 1? Yes, Hubert. No, Hubert. I don't know, Hubert. Forget it. B is equal to, well, 20% of 30. 10% of 30 is 3. So 20% of 30 would be what? Now, let's look down here and say what they said. It is 10 a.m. There is a 20% chance that your friend will arrive in the next what? 6 minutes. Let me ask you a question. Is this little 6-minute prediction, is it more accurate than any other prediction that we can do? Yes. Why? Because time cannot be what? It cannot be changed. So therefore, anything that we have in the past, any observations that we have in the past pertaining to time, unless the person changes their spots, it's not going to change because time doesn't change. What's the only variable that has to change? The person. And a leper usually does not change what? Good parents. Okay? What's the leper have to do with time? Whose fault is it? Your parents. Leper never changes its spots. All right, I need to get the roll right quick before y'all stand up and make your way out of the room.